Solve the second order homogeneous linear differential equation with constant coefficients. Here the constant coefficients are -1 and -2 or 1 and 2. The coefficients are constant coefficients are 1 and 2, and this is the given second order homogeneous because in the right hand side you have 0. So second order homogeneous linear differential equation with constant coefficients, and here the conditions are given. Y0 equal to 3, that means y equal to 3 when x equal to 0. Sometimes it is written that y is equal to 3 when x equal to 0, and sometimes it is written y0 is equal to 3. So you have to understood that this means y equal to 3 when x equal to 0. Similarly, sometimes it is written that y dash 0 is equal to 0. This means the first derivative of y with respect to x, that is equal to 0 at x equal to 0. This can be written as y dash 0 is equal to 0. So these are the given initial conditions, and using these initial conditions you have to solve the given second order homogeneous linear differential equation with constant coefficients. So this is the given equation. So it is suppose equation number 1. Let the solution of the equation is y equal to e to the power mx. So the first derivative will be equal to derivative of y with respect to x, that is equal to m into e to the power mx, because of it is a exponential function. Then we will calculate the second derivative. Then the second derivative will be equal to derivative of second derivative of y with respect to x, that will be equal to derivative of this, that means m is m square e to the power mx, because m is a constant. So if you put the value of y, first derivative of y with respect to x, second derivative of y with respect to x in this equation, then you will get second derivative of y with respect to x is m square e to the power mx. So m square e to the power mx minus first derivative of y with respect to x, so minus first derivative is m e to the power mx, so minus m e to the power mx minus 2 into y. So 2 into y value is equal to e to the power mx. So e to the power mx, that will be equal to 0. And if you take common e to the power mx, then what will get? If you take e to the power mx common, in the bracket you have m square minus m minus 2, that will be equal to 0. Since e to the power mx is not equal to 0, because of it is the solution of the equation, and the solution is not equal to 0, you have to find out the solution. So this value in the bracket, that is m square minus m minus 2, will be equal to 0. And this equation 2 is called the auxiliary equation. You have to remember it. This equation is called the auxiliary equation or characteristic equation. And if you solve the auxiliary equation or characteristic equation, that means this term, that is m square minus m minus 2, this is a quadratic equation. If you solve it, then you can find out the roots of the equation. And you know how you find out the roots of the equation, quadratic equation. So m square minus m minus 2 equal to 0. So m square, m can be written as minus 2m plus m, minus 2 is equal to 0. From these two terms you take m common. So in the bracket you have m minus 2, and here if you take 1 common, then in the bracket you have m minus 2, that will be equal to 0. So m minus 1, sorry, m plus 1 into m minus 2, that is equal to 0. Then you have two values of m. One value will be, if m plus 1 is equal to 0, m will be equal to minus 1, and if m minus 2 is equal to 0, m will be equal to 2. So you have two roots. Suppose one root you write m1, that is equal to minus 1, and another root you write m2, that is equal to 2. So here the two roots are real and distinct, and if the two roots are real and distinct, the solution of the equation can be written as y equal to c1 into e to the power m1x plus c2 into e to the power m2x. and m1 value we have found out, it is equal to -1, and m2 value is equal to 2. So the equation will be equal to y, that is equal to c1 e to the power minus x plus c2 into e to the power 2x. Suppose this is equation number 3, and here we can find out the value of the constants, that is c1 and c2, by applying the initial conditions, and the conditions are given y equal to 3 when x equal to 0. This condition is given. So when if you put x equal to 0 here, e to the power 0, this will be equal to 1, e to the power 0, this will be also equal to 1. So c1 plus c2 will be equal to 3, because y value is equal to 3. So c1 plus c2 is equal to 3. So this is equation number 4. Now you find out the derivative of y with respect to x, because in the second condition it is given that derivative of y with respect to 0 is equal to 0 at x equal to 0. That is why you have to find out the derivative of y with respect to x. So if you differentiate equation 3 with respect to x, then the differentiation of this c1 e to the power minus x will be equal to minus c1 e to the power minus x, and derivative of c2 into e to the power 2x will be equal to 2c2 into e to the power 2x. So suppose this is equation number 4. Now you apply the conditions, given conditions, that is the derivative of y with respect to x equal to 0 at x equal to 0. This is given. This is the initial condition. So dy by dx equal to 0 means this is equal, the left hand side is equal to 0. At x equal to 0 means this right hand side will be equal to minus c1 plus 2c2. So minus c1 plus 2c2 will be equal to 0. And suppose this is equation number 5. So you have two equations to find out the c1 and c2. From equation 4 you have c1 plus c2 is equal to 3, and from equation 5 you have minus c1 plus 2c2 is equal to 0. So c1 plus c2 is equal to 3 and minus c1 plus 2c2 is equal to 0. Now you add the two equations. If you add the two equations, then c1 cancels. So this c1 will cancel. So here c2 plus 2c2, that is equal to 3c2, and 3 plus 0, that is equal to 3. So c2 will be equal to 3 divided by 3. So c2 value will be equal to 1. And we have found, and previously we have found out this equation. Either you put here or in the equation 4, in equation 4 either you put the value of c2, or in equation 5 you put the value of c2, so that you will get the value of c1 is equal to 2. If you put c2 is equal to 1, this will be equal to minus 2, and minus 2 if you take this side, this will be equal to, sorry, plus 2. If you take it in this side, this will be minus 2. So c1 will be equal to 2. So when you find out the value of c1 and c2, you put the value of c1 and c2 in your equation 3. So y value will be equal to 2 into e to the power minus x plus 1 into e to the power 2x. So this will be the required solution of the given second order homogeneous linear differential equation with constant coefficients. Thank you.